Answers to assignment questions. Question 101. Half a kilogram of water in a metal container is heated from 22 degrees Celsius to 40 degrees Celsius. The total energy required will be Q1 plus Q2, and that is to be supplied by the heater, which provides a power of 140 watts. In this way, you may find the time of heating. Question 102. Which one may keep you warmer? A kilogram of iron at 100 degrees Celsius or a kilogram of water at 100 degrees Celsius? The answer would be water, because of its higher specific heat capacity. In this way, when it cools down to 37 degrees Celsius, having a temperature change of 63 degrees Celsius, the energy released by water will be much more. Question 103. It is an electric heater that provides a power of 250 watts. However, energy is being lost to the surroundings at 40 watts. That means in each second, the heater provides 250 joules of energy, but 40 joules of energy is lost. So only 210 joules of energy is absorbed by the water in each second. Altogether, in 10 minutes, there are 600 seconds. We may calculate the total energy absorbed by the water in this way, and that will raise the temperature of water by 35 degrees Celsius. And in this way, you may calculate the mass of water. Question 104. Again, you have to calculate the time of heating, and that is 0.8 kilogram of water to rise a temperature of 40 degrees Celsius. The power of the heater is 300 watts, but the energy is losing at a rate of 50 watts. So, you have to calculate the power absorbed by the water, which is 250 watts. In this way, you may set up the equation, and then you may find the time of heating. However, the answer that you have found in the last question is a bit smaller than the actual time taken. You know why? Because the given power loss, 50 watts, is only the power loss at 30 degrees Celsius, but at higher temperature, then the power loss will be higher. And now, heating the water from 20 degrees Celsius to 60 degrees Celsius. More than half the time, the temperature is higher than 30 degrees Celsius, and so the average power loss should be higher than 50 watts. Question 106. In this question, you are given a temperature time graph, and I think you may better refer to this point, which is time equals to 40 seconds, and at that time the temperature is 26 degrees Celsius. In other words, the 1.5 kilogram of liquid has been heated for 40 seconds, and then its temperature is increased by 4 degrees Celsius. In this way, you may calculate its specific heat capacity. For question 107, would you please do the correction here? Question 108. First, which one is oil, the dotted or the solid curve? The answer is the dotted curve, because for the dotted curve, the temperature changes more quickly, and because oil has a lower specific heat capacity, then that's why its temperature may change more quickly. For part B, you have to calculate the energy absorbed by oil when its temperature increases from 17 to 22 degrees Celsius. The temperature changes 5 degrees Celsius, and this is the specific heat capacity for oil. This is the mass, and in this way you may calculate the energy absorbed by the oil. For part C, you have to refer to the graph to find the temperature at 40 minutes and 50 minutes. At 40 minutes, the temperature of oil and water are both 22 degrees Celsius. At 50 minutes, the temperature of water is 14.5 degrees Celsius, and then that of the oil is 12 only. And so in this way, you may calculate the energy released by oil and by water respectively. Question 109. In this experiment, we have no stirrer, but it does not affect the result because metals are good conductors of heat. Metals can conduct the heat very well inside the metal so that the temperature will be uniform inside the metal block. Question 110. So can we do the same experiment for glass? Answer is no, because glass is not a good conductor of heat, so temperature inside a piece of glass block would not be uniform. Question 111. Why we have to add a few drops of oil into the hose? Because the oil may improve the thermal contact among the metal block, heater, and thermometer, so that heat may conduct better. Question 112. The specific heat capacity of aluminium is in fact 900, but our experimental result is much higher because there's heat loss to the surroundings. So we have to supply even more energy. Question 113. So what's the improvement of the setup? To reduce the heat loss to the surroundings, we may wrap the metal block with cotton wool, or we may put a piece of foam or wood under the metal block to reduce the heat loss to the surroundings. Question 114. So 7,000 joules of energy is supplied to 3 kg of metal block. You may then apply the equation 9 and 7 to calculate the specific heat capacity in joule per kilogram per degrees Celsius, or calculate the heat capacity in joule per degrees Celsius. Three 3.4. Mixture is a calculation based on conservation of energy. In this section, we will mix hot and cold water or other liquids together, and we are going to find the final temperature of the mixture. As there is something hot, there is also something cold, and so the energy released by the hot object, the heat loss, will be absorbed by the cold object, the heat gain. That is to say, the heat loss by hot objects will be equal to the heat gain by the cold objects. And let's take a look of the following experiment.
Here are two empty polystyrene cups A and B. Measure the mass of each cup with an electronic balance. Then, half fill cup A with cold water and cup B with hot water. Measure the mass of the two cups again. Calculate the mass of water in each cup. Then measure the temperature of the water in each cup. Then quickly pour the cold water into the hot water. Stir the mixture. Measure the temperature of the mixture. Calculate the energy gained by the cold water and the energy lost by the hot water. Are the two results exactly the same? Why?